Hello, and welcome to the very first episode of Cabin Fever Astronomy, brought to you by the Boonshoff Museum of Discovery in Dayton, Ohio. I am Joe Childers, Astronomy Manager at the Boonshoff, and your host today. Cabin Fever Astronomy is planned to have new episodes daily, as long as the museum stays closed to the public, which as of March 16th is through the end of March. Today's topic is the planet Venus. Venus is the brightest planet, outshined only by the moon and the sun. No planet makes its own light, but rather we can see it only if light comes from the sun, bounces off the planet, and then comes to our eyes. The pretty clouds that you see here reflect light well. Astronomers would say that it has a high albedo, meaning that most of the sunlight that hits it bounces off and is able to come to our eyes. The first of four segments that we're going to have in each show is called The Sky Tonight. And so if you are cooped up and you go out in your backyard, what are the sorts of things that you can see in the night sky, even if you live in the city where you have a lot of light pollution? So we're going to talk first about how to find Venus in the evening sky. So it is indeed after sunset. In Dayton, it's setting around 11:30 at night. It's in the west, and it's ridiculously bright. You will not be able to miss it. It doesn't look at all like a star. It's much, much brighter than any other star. And sometimes it's even brighter to me than an airplane's landing lights. But of course, it doesn't have any blinking lights, and it doesn't move across the sky any faster than the stars do, or the moon. So that wasn't very hard. Go west, look up, whoa, there it is. So what we're going to do instead here is a project that you can try the next time it's clear where you're at, and that is finding Venus in the daytime sky with just your eyes. So here's what you need to do first. You're going to look when it's due south, so not just any time, but you want to know which direction to be looking. And fortunately, this is pretty easy to discover. You also have to calculate the angle with the south horizon. So how far, not only which direction are you looking, but how far up are you looking? And then there are some things that could help you to do this easier. When is it due south? Well, here is a screenshot from this website. You do need to set your location. If you don't do that, then it will be giving you times for Greenwich, England. And the one that we are interested in is the transit one, the one in the middle there. So today, on March 16th, the Venus will transit at 4:33 in the afternoon. Now, how high is it? Well, this website tells us that too. The altitude is the angle from the south horizon up to where Venus is. So you're going to want to stand on the east side of a building so that you're in a shadow, and you're going to want to look south, and you're going to want to look at about 68 degrees up. How can you do that? Well, protractor helps. It turns out that altitude by angles can be really tricky to estimate. You can also use binoculars to help you find it first. It isn't really that hard to do with just your eyes. What helps a lot, knowing which direction and how far up to look, is that you can study one part of the sky until it comes visible, as opposed to roaming your eyes all around the sky and hoping that you'll stumble upon it. Once you figure out how to find Venus in the daytime, here are three other planets that you can see in the daytime. Although these, you do need to have special times of the year and special circumstances in order to see them. For instance, seeing Mars will be possible again in late October and November of this year. And Jupiter, it's usually when it is in the eastern sky around sunset. Jupiter is pretty easy to see, again, once you figured out where to look. Mars, though, varies in brightness so much that you really can only look for it this way about a few weeks after opposition. That's when it's in the low in the evening sky. So that is finding Venus. Now, the second segment in our shows is going to be Tour the Universe. So we're going to go to a different place and tell you about it. And guess what? We're going to Venus today, of all things. So Venus for a long time was considered to be Earth's twin. And especially in the early days of science fiction, in the early 20th century, Venus was this paradise where you have all sorts of exotic creatures that would be like a vacation land. Here is why that was thought. Well, first of all, Earth is not much bigger than Venus. So Venus is 95% of Earth's diameter. So that makes it 90% its surface area and 86% its volume. The surface gravity on Venus is about 90% Earth's gravity. So that part wouldn't be uncomfortable at all. But it's closer to the sun. So yellow here is Venus's orbit and blue is Earth's orbit. So because it's closer to the sun, it was expected to be warmer. We can also see those clouds in telescopes. And so we expected it's covered with water clouds. It's either going to be an ocean world or it's going to be a swamp world. But some people thought that somehow it was going to be a desert world. In any case, hot, like the hotter climates here on the Earth because it's closer to the sun. So is it Earth's twin? Not so much. This picture here, which we're going to be talking about for a few minutes, shows us the temperature, that's the blue, the black line, from the surface over on the right where it's 500 degrees Celsius or 860 degrees Fahrenheit, and then dropping as it goes higher up into the atmosphere, and then at the very outer parts of the atmosphere, it becomes hot again. So the first thing that we have different is that the clouds are not made of water. They're made of pure sulfuric acid. So if it rains on Venus, and there's no reason why it wouldn't, then the rain is acid. And even on Earth, when we go to a chemical lab, the sulfuric acid that we get is diluted to some strength. It's called with the molarity of the acid, I think. But there's no water at all on Venus. So this is like really pure sulfuric acid. So the clouds that we see, that's why they're tinged yellow, they're made of sulfuric acid. And then below that, you have sulfuric acid just as water droplets making fog or haze, as they're saying here. Instead, it's sulfuric acid droplets. But eventually, even that acid rain would evaporate because as you get closer to the surface, it gets hotter. So there's also the air pressure on the right. A bar is a unit of atmospheric pressure that is similar to the pressure of Earth's atmosphere at sea level. It's like about 100 meters above sea level. So you can see that it's 90 times the air pressure on the Earth at the surface of Venus. This means that the atmosphere of Venus is much, much thicker. The atmospheric pressure, so that is the pressure of the air on Venus, on the surface of Venus, is the same as the ocean pressure that we would experience on Earth about half a mile below the ocean surface. Now, we have, of course, bathyspheres, I think they're called, that are designed to go like even all the way down to the bottom of the Marianas Trench. But military submarines, which is the sort of thing we normally think of as a submarine, most of them can only go like a quarter of a mile deep at the very most. So the surface of Venus is twice the pressure from air alone, not from water, but from air, that submarines are designed for here on Earth. And now, the temperature, which I had out of order earlier. Most of the atmosphere on Venus is carbon dioxide, and we know that that is a greenhouse gas. It is so thick there that it holds in the infrared light extremely well. The greenhouse effect on Earth happens when infrared light, or what we would say heat energy, radiating out up from the Earth's surface, bounces off of carbon dioxide or water vapor in our atmosphere. And so instead of leaving the planet and going into outer space, and that's a way that the planet cools, instead that is trapped. Well, on Venus, that got out of control and became a feedback loop. That's why it's called a runaway greenhouse. And so that's why, as I said earlier, 860 degrees Fahrenheit. And because of the thickness of the atmosphere, that is everywhere. So noon or midnight, North Pole or equator, is pretty much that 860 degrees everywhere. So it is quite unlikely that humans are ever going to land on Venus. But on this chart here, the line between the dark orange and the light orange, that's one atmosphere. The pressure is okay. And so there are suggestions that we might be able to have floating, like balloon gondola or something like that, space probes or even spacecraft for astronauts orbiting about 50 kilometers above the surface of Venus. Of course, you have to figure out what to do about the sulfuric acid, but at least you're not frying or being crushed. So Venus is not Earth's twin. The third segment that these shows will have is called Astrophysics Lite. So we're going to take something that, people know about it, but they don't quite understand it, or it might be something that's easy to understand but not well known. And then we will explain that in using simple language. Today it's probably the latter category. It's probably not well known that Venus has absolutely no water. And so in order to explain this, we need to talk about how planets lose their atmosphere in general, and then the contribution of Venus's magnetic field, ozone layer, and then chemical reactions. So let's start off with how you lose gases from a planet's atmosphere. So this chart on the left has temperature along the bottom, and it has escape velocity along the left. So the higher you are on that chart, the faster a molecule of gases needs to be going to escape from the planet's gravitational influence and be lost to the planet's atmosphere. The left to right axis is how hot it is. Typically, this is going to be closer to the sun, is warmer. Notice, though, that Venus here is at a little bit more than 300 degrees Kelvin, which is a lot less than the surface temperature. What matters for escape velocity when you're trying to figure out whether a planet's going to lose its atmosphere is the temperature at the top of the atmosphere. So here's what happens. Temperature, from a physicist's point of view, is the average velocity of the molecules in a gas. And it follows a bell curve. So at a given temperature, at the top of Venus's atmosphere, the average temperature gives you the average velocity. And then some particles are going faster and some particles are going slower. The chart here says that Venus is able to hold in water vapor, ammonia, methane, and other molecules, but that helium and hydrogen can escape, and they can also escape from Earth's atmosphere. So if Venus is able to keep water vapor, that is, most of it isn't going to just leak away because of Venus's gravity being too low or it being too hot, then how does it lose its water? Well, the first thing is that Venus has no magnetic field at all. Earth has a magnetic field that protects us from the solar wind. Solar wind are charged particles, either protons or helium nuclei, that are streaming away from the sun. And these spread out into the solar system. When we have the aurora borealis on the Earth, the northern lights, that's when the solar wind is being funneled by our magnetic field into the atmosphere at the two poles. And so it makes that ring of aurora. And Saturn and Jupiter have an aurora also. For the most part, though, Earth's magnetic field pushes the solar wind away from us and protects us from it. But Venus doesn't have that. And so the solar wind, kind of like just hitting molecules, can give them a boost and increase their velocity such that they can escape. So if you picture a water vapor molecule on this chart below Venus on the green to blue line, if it gets hit by a solar wind particle in just the right way, well, then its speed is going to jump up, and then it will be above Venus on this chart and lost. Another problem that Venus has is that it does not have an ozone layer. Ozone is a molecule made of 3 oxygen atoms, whereas the oxygen that we breathe is made of 2. Ozone protects the Earth's surface from ultraviolet radiation. And ozone happens because we have extra oxygen in our atmosphere. The only way that I'm aware of that a planet can get extra oxygen in its atmosphere is through life doing photosynthesis. Well, that of course is not happening on Venus. So without the ozone layer, Venus is not protected from UV radiation. And ultraviolet light can break a water molecule apart. So even without the solar wind hitting something, water vapor on Venus is constantly being turned into hydrogen, which does escape, and oxygen, which Venus can keep. But still, it's not water anymore. We also have the problem that once you get oxygen in the atmosphere, it wants to combine chemically with pretty much anything it can, namely the crust. So Venus's crust gathers through chemical reactions all of the oxygen that is released when ultraviolet light breaks apart the water molecules. So in sum, Venus has no water because it can't keep water intact to ultraviolet. It can't keep the solar wind away from just knocking it out of there. And if it breaks down the molecule, there is no oxygen lying around to combine with hydrogen again because it goes into the crust. Our last segment in each episode is called Space Robots. And so we're going to talk about spacecraft and what was the purpose of them? What did we learn from them? Well, with Venus, there are 2 significant spacecraft missions or programs, with many others, but these are the 2 that jump out when you think of spacecraft going to Venus. The first one are Venera and Vega, which were launched by the Soviet Union back in the 70s and 80s, roughly 24 of them. Some of them would land, some of them would just have parachutes and be sampling the atmosphere. Some of them would orbit and use radar to map the surface. And I'm afraid that lots of them just didn't do what they were supposed to do and the mission was lost. But because of the extreme conditions on the surface of Venus, and so here you can see kind of like a fisheye view from, I believe this one is Venera 13. I'm not quite sure. I should have remembered that. But in any case, Venus is just a wasteland. You know, I look at pictures of Mars, which are a lot more common. I'm like, where's the green? And it's hard to imagine living in a place without green. But I guess if you do eventually be one of the ones that colonizes Mars, you'll get used to that. So that was the Soviets' contribution. The big one from NASA was the Magellan spacecraft. The white and orange and dark browns that you see here are false color for altitude. So white is the highest and black is the lowest. We can't see through the clouds with telescopes that use visible light. Not even Hubble can do that, but radar can. And some of the radar maps taken of Venus were actually taken by the huge radar telescope Arecibo down in Puerto Rico. But to get a really good map, we had to send an orbiter. And so the vertical streaks that you can see up towards the upper right of the word Magellan are coming from where some of those orbits didn't quite overlap the way that they needed to. Two things to notice here: there are not very many craters on Venus. There's two possible reasons for that. One, well, Venus's atmosphere is just very thick, and it is friction from going through the atmosphere that burns up meteorites. Meteors, rather, makes them not become a meteorite. They get destroyed in the atmosphere. And so that's going to happen to more meteoroids with Venus's thick atmosphere than Earth's relatively thin atmosphere. The other possibility, since the surface of Venus is entirely cooled lava, basalt, that Venus kind of repaves itself every 10 to 100,000 years. And so there was just a new surface made fairly recently, and so there just hasn't been that much time for craters to form. Now, there are volcanoes on Venus. Until just recently, we assumed that they were all extinct. In the past few years, there's been some articles that have suggested that maybe they're detecting active volcanoes on Venus. But I want to draw your attention to the right-hand side here where we have those circles, the larger circles. Those are called pancake dome volcanoes, and they're unique to Venus. They're kind of like a shield volcano here on Earth, such as the Hawaiian Islands. You know, the lava that's coming out of Hawaii and running down to, Kilauea, I think, running down to the ocean, it's runny and it just builds up over time. And each of the Hawaiian Islands is a volcano that was built up over time just by more lava coming out and hardening and making it taller and taller. The pancake domes are similar, but not quite the same. And as far as I know, we don't really have a definitive answer on why they might have that, that particular shape. So that is your cabin fever astronomy for Venus. Remember to try and find Venus in the daytime, and we'll come back tomorrow and we will have another episode. Thank you for watching, and stay safe.